Oh, okay. About the fall season, one thing that a lot of people think of is like apples, apple juice, you get your caramel apples and stuff. Well, another thing is apple cider. And the difference between apple cider and apple juice is that all the sediment and pulp isn't really filtered out of cider as it is apple juice. And this leaves more opportunities for different things to be left in it, and which leads us to our experiment that we're going to be testing different apple ciders for the concentration of different metals in it. And we're going to be testing for copper, aluminum, lead, manganese, and aluminum. And we'll be testing these with non-alcoholic apple cider. We'll be testing these in non-alcoholic apple cider to determine the amount of levels in there, and we'll be comparing them against the FDA regulations against drinking water, because there really aren't too many FDA regulations against different concentrations of metal in cider. So we're going to be using the concentrations of drinking water, and this will help determine if there are more metal ions in apple cider than compared to like a commercial brand that we're going to use or the drinking water regulations.
Okay, the two major sources of contamination in apple cider are from what's in the soil that apple trees grow in. Meat pesticides prior to 1980 contained high levels of lead and copper, and while these have been discontinued in the 1980s, those ions are still present in the soil to be taken up by apple trees. And the other major source of contamination is in the actual processing, where the apple cider is run through a metal mill, and then it's stored in metal containers prior to bottling, and potentially metal ions could leach off from that and find its way into apple cider.
Arsenic is a common component found in pesticides that are not allowed in the U.S. The levels of that can be higher in other places, so we assume that the higher levels would be found in the process versus the orchard, because the apples could be from anywhere not in the U.S. We found a study in 2012 where arsenic and lead levels were tested in different juices, mainly in 20 different types of apple juice. And in this, we found that then 94% contained lead levels, and arsenic was found in all of the apple juices. And of those 20 juices that contain the arsenic, 34% of them had higher levels than FDA regulations. So we're finding that we're going to look to make sure if the match of the orchard and the process doesn't have higher levels in the process.
We'll be using atomic absorption spectroscopy to figure out how the levels are in the apple ciders. So basically an AAS has a lamp that emits an electrode that identifies the specific element in the solution. And there are different lamps to go with the different solutions that we'll be testing. So we'll use that to determine the levels. We'll be composing an apple cider solution for each one of them that's diluted. And each of our elements will have a stock solution that we can compare to. And then we'll have a control group to compare through all the metals.
And as Ashley mentioned earlier, unlike apple juice, apple cider still has the solid components of the apples in the juice itself. So it's important that we extract the analytes from the solid component. So what we're going to be doing is adding a nitric acid hydrogen peroxide solution overnight to the cider, which is going to help break down the solid components. And then we will be doing a series of evaporations and heating in a Teflon vessel. Now this allows us to add pressure and heat to the heating process in a microwave, which will help further concentrate the analytes in the cider itself. So once we make this concentrated solution, we're going to dilute it with, we're going to dilute the solution, and we'll actually add a titrin to a small amount of, titrin is a detergent, so we'll add a small amount of that to our samples, and that's going to help the cider run through the AAS more easily without anything getting stuck inside of it. Additionally, we're going to be adding matrix modifiers to each of our sample solutions. And what this is going to help do is essentially reduce the background noise of the other elements besides the specific analyte we're looking for, as well as help extract that specific analyte from the cider when being analyzed in the AAS. So, any questions?
Were you able to see the country of origin on some of these ciders?
Yeah, for a lot of the ciders, or at least one I found in the store, the concentrate itself comes from Chile, Turkey, China, and Peru, and Mexico. And so although we still use, or in the past we've used arsenic and lead, copper at higher levels in our pesticides, and we still would find those in groundwater, in those countries it's less regulated, so that's where our hypothesis that the commercial cider will have higher levels of these elements come from.
Then you have some that's directly off the farm, right?
Correct.
Yeah.
We have 3 different
Okay.
ciders, one from Quant County, one from Sheboygan County, one from Fond du Lac County.
'Cause- Go ahead.
Based off of like the different regulations that the countries have, do you have any predictions for like which ciders from which countries are gonna like specifically be higher, or just in general, is it just the commercial?
Yeah, a couple of the studies we saw, the countries, ciders produced from Asia have higher levels. So I guess since the concentrate we have for our commercial brand contains something from Asia, I would like hypothesize that could have higher levels. However, that's also mixed like with concentrates from other countries. So I don't know if I can really isolate like it's not just from Asia.
The concentrate that you have in all of those countries?
Yeah, I know, I was really surprised. Yeah.
Thank you.